This little video is about USB cables and their performance. I'm using this Keysight power supply to demonstrate different cable performance. So I've collected a bunch of breakout panels and breakout connectors for USB cables, power meters, and I've built some to present loading for USB cables. But for this exercise, initially I'm just going to use connectors that have been shorted. So what I've done is I've taken USB connectors and shorted the power pins. So that's this set. So we've got a USB A, B, mini B, micro, and an A. And of course on the power supply I've got a USB A connector as well. What I'm going to do is just set the power supply to be a constant current, and then I'm going to measure the voltage across the cable with the output shorted. So that will give me the resistance of the cable and its voltage drop. So I'm setting this to 1 amp. And I'm going to put 1 amp through the connector and the cable. And that gives me a really easy way to get the resistance, because the voltage across the cable divided by 1 amp is the resistance. So the voltage reading and the resistance reading will be exactly the same. So if this is 0.1 volts, it will also be equal to 0.1 ohms in the cable. And just to show what kind of resistance we're getting in the apparatus, I'm going to connect this shorting connector directly to the connector that's on the power supply, and we're going to put an amp through it. So if I do that, I get 29 millivolts with 1 amp through this system here. So there's a 29 millivolt drop, which is 29 milliohms. And it includes both the connector at the end of the cable and the connector at the start. This connector at the start has heavy traces coming to it, so it's keeping that voltage drop to a minimum. And I have collected a whole pile of cables that we can try. Here's one with a braided cable, fairly short. And just to try it out, it's a USB micro connector, so I'm going to plug on a shorting connector here and turn it on, and we can see that it's dropping about 0.4 volts, 0.36. So this little cable has 0.36 ohms in it, of course minus whatever we had there before, 29 milliohms in the measurement system. And that's just a short little cable. If we take a longer cable, let's look at this gold braid cable. It's 1 meter long. It's also a micro connector. Plug it on there and turn it on. And it's 0.85 volts or 0.85 ohms. So it's over 0.8 ohms in this cable. And notice that it's dropping 0.8 volts. That means if we have 5 volts at the power supply, there's only 4.2 volts reaching the actual equipment. So let's try a longer cable. Here's a 3 meter cable, and it's a USB mini connector, so I'm going to plug on a shorting connector for that and put an amp through it, and it only has 0.73 volt drop, so it's a little bit better cable and it's a lot longer, but still it would be 4.3 volts roughly reaching the equipment. So that wouldn't be good if you're driving on Raspberry Pi. And this is only 1 amp. Raspberry Pi could take more than 1 amp. So here I have a longer cable. This is 5 meters It's a white cable, and it's a micro connector on the end. Let's plug that in and see what it reads. 2.1 volts. That's how much it's dropping through the cable. So we would have less than 3 volts reaching our equipment with this long cable if we were drawing just 1 amp. So these long cables aren't really good for supplying power. They're just maybe good enough to supply signals. So continuing on with more different cables. Here's some cable that's got translucent blue insulation on it, but you can see that it's shielded underneath that. And this one has a USB-B connector on the output, so let's find a shorting connector for that. This is 1 meter long, and we're going to short the output, put 1 amp through it, and it has 0.7 volts across this cable. So again, even though it looks like a nice heavy-duty cable, it's still dropping over a half a volt over 1 meter. And here's a much shorter version of the same cable with a mini connector on it, just to see what that looks like. So this one is 1 foot long, and it only has 0.3 volts drop across it. So if you're going to use this for power, you want a short cable like this. Here I have a 2 meter extension cable. So this is supposed to be good for anything, and let's plug a shorting connector on it. Put an amp through it, and it has a whopping 3.9 volt drop. It's crazy. You can't use this for powering anything. So you really do need to be careful about testing your cables if you want to be putting any kind of significant current through them. They may look good, you know. Let's see here. Here's a really beefy little cable. It's got thick insulation. It's only about 80 centimeters long. Let's put some current through it, and it's dropping over 0.4 volts. So it looks beefy, but even on this fairly short cable, it's dropping a little bit more than I would like if you're drawing an amp from the system. However, I have here a 3 meter brown cable, nice and flexible, and I ordered this one specially. It's a micro connector. So this is 0.3 volts, and that's through a 3 meter cable. This cable happens to be 20 gauge wire, the heaviest USB cable I could find. So these other cables all have much smaller wire in them, and this is about the limit of what I would call acceptable for a power supply, where you're drawing an amp from the 5 volts, because a lot of equipment may be rated at 5 volts, but it'll run fine off 4.75 or even 4.7. But you need a cable with 20 gauge wire to get there. So if you're going to be supplying power of any significant amperage, you want cables with at least 20 gauge wire in them. And it's really nice that you can set up a simple test like this with a power supply that can do constant current like this and measure the voltage and the current both very accurately.